Good day, grade 12s. Today we are going to be looking at technical mathematics. Then under technical mathematics, we'll be looking at application of calculus. This is the topic that we are going to be going through it for today's lesson. And then before we can start grade 12s, especially for technical mathematics learners, please go to DBE website and look for the examination guideline for technical mathematics and try to go through that document. It's a very important document for technical mathematics. Before you can go and write your final examination, it's a very, very important document. If you can just go through it, because it outlines the important information that you should know for each topic under technical mathematics. All right, and then let's see what we are having for today's lesson. And then under content, we have differential calculus and integration. Under that, we have application of differential calculus. This is the topic that we are going to look at for today's lesson, as well as the integration. Those are two topics that we are going to be working on for today's lesson. All right, before waste of time, let's get into the application of calculus. And then application of calculus, it say the step to solve the maxima and the minima problems. First, we have to highlight what question asked and make an expression of what has to be maximized or minimized. Or what we can do, we can draw a diagram if possible. And then the third point, it says, if there are two variables, eliminate one using the given information and the simultaneous equation. Write f of x and f prime of x. And then set a derivative equal to 0 for maximum or minimum. Meaning, when you are calculating maybe the value of x, make sure that after you derived, then you are going to equate it to 0 so that you can be able to determine the maximum or the minimum values. And then the last point says, in order to maximum or the minimum for an object, for f of x, then determine f prime. Remember f prime meaning we have to derive. We have to do derivative of f of x. Then after doing the derivative, we then equate it to 0 so that you can be able to solve the value of x. All right. So that are the steps that you should follow when you are answering questions under application of calculus. Then we are going to be looking at the examples where we are going to be calculating the maxima and the minima values. And then that's where we are going to be learning on how do we calculate or how do we solve questions under application of calculus. Let's have an example under application and see how do we go through that. All right. The first statement says a piece of rectangular sheet metal with the dimension of 80 millimeter and 50 supposed to be end there, and 50 millimeters is used to create a rectangular jewelry box. The square corners of x millimeter are cut out of the sheet metal and the edges are folded up so as to form a box without a lid of depth x millimeters. That is what we are having from this scenario. Now, according to that scenario, they are saying, yes, the length from this point up to this point is 80 millimeters. And then from this corner up to this corner, there is 50 millimeters. But now we have to do what? To cut out the square from these corners. and then that is going to be X millimeters, meaning you cut this side, you also cut this side here, and then you also cut here, you cut this piece out, you cut this piece out, you cut this piece out, you cut this one as well, and this side. Then after removing this piece of metal sheet, then we are going to fold it up, right, to form a box. Now they are saying the length from here up to there is X millimeter, and then as well as this side is X millimeter. The same applies with this one here is X millimeter, and also this one is X millimeter, right? Now when you fold this to form a rectangular box, then remember it's going to give us our height as X. Now if I can just draw in an isometric view, and let's see how it's going to be like. Then if we can have something like this, let me just try to draw that box. We are going to have something like this one. After folding that, then we're going to have this box, right? We're going to have something like this. After we have cut this out, we also have to cut this one out. We have to cut this one out, and then as well as this one, and the last one. So after cutting out those corners there, then remember we are going to fold all those edges, and then it's going to form a box like this now. Now remember, if we now have to fold this side and as well as this side, then the distance or the length is no longer 80 millimeters. Then we'll have to look for that length. The same applies with this width. Is no longer what 50 millimeters, because now we are going to be folding all those edges so that we can form a box. Then we'll have a new length and a new width, and then from here up to there is going to be a new length. From there up to this point there is going to be what, the width, the new width. And then of course the height is going to be what, equals to X. Now the first question it says show that the volume of the jewelry box is given by the formula F equals to 4x cubed minus 260x squared plus 4000x. Then we have to prove the volume of this jewelry box is given by this. Now we have to prove that. All right, now question is, how do we prove that? Now since we had first to cut out those corners, and then we folded this metal sheet, then now we'll have to look for the new length. Now if for instance from here up to there, let me just indicate, this is going to be X, this is X. The same applies on this one. From here up to there, the length is going to be X. Now if you fold this one, then it's going to be 80 minus this 2x, which is going to be 2x. This is the x plus this x is going to give us 2x. Then now we are going to have 80 minus 2x as a new length. The same applies with this width. Then also this side we are having what is going to be x, and then also this side is going to be x there. Then if you minus out this 2 x, then it's going to be 50 minus 2x. All right, that is going to be our new width. All right, then let's see on the solution on how do we calculate, how do we show the volume of jewelry box. Now first to write the formula for the volume of that box, and then now the length, as we were saying, that is going to be 80 minus 2x, and then the breadth or the width, breadth and width is the same thing, then it's going to be 50 minus 2x. Of course, the height is going to be x, because remember from this point up to there is x. Then if you fold this edge, you fold it up, then of course the height is going to be x as well. Now the second step, we're going to substitute the value of L, which is the length, which is 80 minus 2x, and then B, breadth, which is 50 minus 2x, and then height is what? Is x. Thereafter, we're going to open the bracket, and then after opening the bracket, then we're going to have 4,000 minus 160 minus 100x, and then plus 4x squared. Then we're going to open that bracket again with this x outside. Then now it's going to give us 4x cubed minus 260x squared plus 4000x. So we have just proved that the volume of jewelry is going to be this. All right. The second question says determine the value of x so that the volume of the box is a maxima. Is a maxima. Now, every time when you have to answer this question, where you have to now solve a variable, for instance, in this one x as a maximum, then we're going to do the derivative of the equation that we have created, which is this one. Let me just remove this part here. Then we'll be deriving this one so that we can be able to solve the value of x. Then we're now solving the volume with respect to x now. Then derivative, we are going to do derivative. We can see we have applied the rule of derivative there. This one's going to give us 12x squared, and this one is going to give us negative 520x plus 4000. Then remember we said we equate it to 0, and therefore so that we can be able to solve the value of x. And then the second step, we can just simplify it, and then we just divide each term with 4. Then it's going to give us 3x squared minus 130x plus 1000. And then you write the factors, and then you solve two values of x, which is x equals to 100 over 3 or x equals to 10. Now, how will you know that which value of x so that the volume of the box is a maximum? You can see from the equation. Where is the equation? Before we can derive this equation here, this equation is a cubic function. We can see the cubic function, and then now if the coefficient of x cubed is positive, then this is going to be the shape of the cubic function, right? And of course, this turning point here is going to give us the maximum value, and then this turning point down there is going to give us the minimum value. Now remember, we are looking for the maximum, right? The maximum. Now between these two values, which is x equals to 100 over 3, which is I think 33,3, and then this one is going to 10. Which one is going to be the maximum value between this one? Of course, the maximum value is going to be the lowest value of x. The lowest value of x then is going to be that value that we are looking for, which is now 10. This is going to be 10 there, up there, all right? Therefore, we say the maximum at x equals to 10. That is the value of x that we are looking for. We don't want this one, but we are looking for x where x equals to 10. Now that is the answer for this question. Now let's proceed. Bricks are to be painted with a special paint for use under water. The bricks are rectangular in shape, and length of each brick is 3 times its length. the length of each brick is 3 times the breadth, and then the volume of the cement is in each brick is 972 centimeter cubed. If h is the height of the brick and x is the breadth, then data express h in terms of x. All right, my dear learners, I always advise learners when you have to answer this application of calculus questions, then we are going to be led by the scenario that we are having. Before we can answer the first question, what are we being given from the scenario? You can see from the scenario we are being given the what? The volume, which is 972 centimeter cubed. Now, before we can start answering the first question, or when you have to answer the first question, then we're going to start with the volume. You write the volume of this shape that we have. In this case, you can see we're having a rectangular a shape or a box. All right. Then the first thing that we have to do all the time, you start with what you are having from the scenario, and then from this scenario now we are having the volume, which is 972 centimeter cubed. Then we have to start writing that formula first. Then it's going to lead us to be able to answer the question. And then it say express h, which is the height, in terms of x. Then you start writing the volume, like I've said, and then you substitute all what you have, and then from there you make h the subject of the formula, and then it's going to give us what? A 324 over x squared. This is the height that we are looking for. All right. Don't forget that we start with what we are having from the scenario. And then the second question says, express the total surface area of each brick in terms of x. Now, you just write the formula for surface area, and then where you are going to be having h as a height h, then you are no longer going to substitute with h, but we're going to substitute with this value that we obtain from first question. The surface area formula for this rectangular box is 2 breadth times length plus 2 times height times length plus it's supposed to be 2 as well here, 2 times h times b, and let's see, yes, supposed to be 2 here, and then this what we are having, breadth, we can see breadth is x, and then we set length, the length is 3 times its breadth. Now we can see breadth is x, then of course the length is going to be 3x because it's 3 times its breadth. Then hence you can see for length we have substituted with 3x there, and then height, of course height we have determined it, which is 324 over x squared, and then the length is the same, 3x there. Then you substitute everything, all right, and thereafter you multiply. Then after multiply you will have 6x squared plus 1944 over x plus 648 over x. Then now this you can be able to add them together, then it's going to give us what? Let me just remove this line. Then it's going to give us 2592 over x. All right. So that is the surface area that we have to determine, and then they said in terms of x. Then hence you can see we are having only x on this one. So that is the question. The last question says calculate the dimension of the brick, which will minimize the amount. We now have to do what? Derivative, because it's talking about minimize. First to write that, now we have to fix this one. Remember the rules of differentiation. We cannot be able to derive if it's in this form, but now we had to write it in this form so that we can be able to factorize. And then from there, you start deriving. This is what we are going to be having after deriving. 12x minus 2582 over x squared, and therefore equate to 0, and then we are solving for x. Now, to get rid of this fraction here, then we are going to multiply each term by x squared. Then if you multiply 0 by x squared, is going to be 0. If you multiply 12x by x squared, is going to give us 12x cubed. And then this is what you are going to have, 12x cubed, and then equals to now 2592. And thereafter, then we're going to divide both sides with 12. Then this is what we are having. So after dividing 2592 with 12, then it's going to give us 216. And then because now we are in need of x, then we need to get rid of this exponent 3. So we're going to put cube root both sides. Then after doing that, then it's going to give us xs equals to 6 centimeter. But because they are looking for dimensions, and then the length, it was 3x. So when you substitute with 6, then it's going to give us 18 centimeter. And then remember, the breadth, it was x, then x is 6 centimeter, it's still 6 centimeter. The height, now remember the height, it was h equals to 324 over x squared. So where you see x, you just substitute with what? With 6. Then it's going to give us 9 centimeter. So that is the dimension of the brick, which we are minimizing the amount. All right. The sides of the base of the rectangular cardboard shoe box are 3x and 2x centimeter respectively. The height is y centimeter. The box is open on the top without the lid at this stage. You can see this box, it's open up there. There's nothing up there. Then you'll see on how we're going to calculate for that. Now, the first question says, if the total surface area of the box is 200 centimeters squared, prove that y equals to this. You can see we are being given what? The surface area, which is 200 centimeters. The first thing what you have to do, write the formula for the surface area, substitute, and then make the y of the formula, the subject of the formula. Then you'll be able to prove that. Let's see. Now you say surface area equals to 2, but now it's no longer 2 here. It's supposed to be 2 width times length plus 2 times height times length plus 2 times height plus width. Why 2 is not there is because it was very clear from the scenario that the box is open on top. It means on top we don't have anything there. Right? We don't have anything, hence we don't have 2. Because if you say 2 width times breadth, meaning we are saying the bottom part, which is the breadth and the length, times 2. If we had if this box was closed on top there, but because it's open, then we're only going to be calculating the surface area of this shape just underneath here. We're going to be calculating for that only, hence we don't have 2 there. All right, then from there you substitute all the values that we are having, and then we add, and then this is what we are going to be having. Now, because we want to make y the subject of the formula, therefore we're going to transpose this as 6x squared to the left hand side. Then this is what we are going. Then from there, because we want y the subject of the formula, we're going to divide both sides with 10x. This is what we did. Then we simplify it, then it's going to give us 20 over x minus 3x over 5. And then this what you have proven that question, And then the second question, express the volume of the box in terms of x. We now have to express the volume. You write the formula for the volume, you substitute. Now for h, we know it's no longer that h is now what, this is going to be our h. Then you simplify it, you open the bracket, and then this is what you are now having. This is the volume that we are looking for in terms of x. The Department of Energy plans to build a rectangular wind power plant having an area of what? Having an area of 360 kilometers squared and surrounding it with a fence. The length of the power plant is x kilometer. Now, write expression for the width of the plant in terms of x. What did I say? From the scenario, what you are having, we are given what? Area. Now, before we can go any further, you just have to write the area of this rectangular box. You write what? We write the area. Now, the question says an expression for the width of the plant in terms of x. Now, let's see the area. So let width be y, because now from the scenario we are being given what? The length as x kilometer. We don't have this side. We don't have this side. So we can call this side what? Y. And then you write the area. This is the area. So make y the subject of the formula, because they are saying we should express this for the width, meaning we have to make width the subject of the formula. And then we can see the width is y in this case. So meaning we are going to make y the subject of the formula then we're going to divide both sides with x. Then this is what we are having. Write down the expression for the perimeter of the plant in terms of x. You write the formula for perimeter. This is P equals to 2 length plus 2 width. Then you substitute your values there, simplify it, then you are having perimeter as 2x plus 720 over x. Determine the dimension of the plant if the perimeter is the minimum. You then have to derive that perimeter, and then you then fix this one first, because you cannot be able to derive if it's a fraction. Then it's going to be like this, and thereafter we can now be able to derive that it's going to give us 2 minus 720x minus 2, and then you equate to 0, and then this is what we are having. And therefore you can see this one, you transpose this one 720 this side, this is what we're going to be having. But because we are solving for x, therefore we are going to cross multiply, and then we divide with 2. Then it's going to give us x squared equals to 720 over 2. Then you put square root both sides, and then it's going to give us x equals to plus or minus 90 kilometers. And therefore, remember, we're looking for that is distance. Distance supposed to be positive, and then hence we are having now xs equals to 19 kilometers. All right. So the dimension that we are having, the length is going to be 19 kilometers, because now we want this side, which is the width. You can just take this 19, you substitute here, so that we can be able to determine what? To determine the width. So you press your calculator, you say 360, you say 360 divide by 19, then it's going to give you the width. All right, because the question is, it was very clear that we should determine the dimension of the plant in the perimeter is a minimum. A manufacturer needs to design a closed box having a base where the length is twice the width, and the surface area of the box must be exactly 120 centimeters squared. Write down the expression for the length and the length and the height of the box if the width is x centimeter. Now, you can see from the scenario we're having what the surface area of the box, which is 120 centimeters squared. So, when you have to answer the first question, you have to start with the surface area formula. Let's see if that is true. This is the surface area, and then from there you substitute your values there. Then you're going to make h the subject of the formula, because now they say the height of the box if the width is x centimeter. Then this is what we are going to have. Then we simplify it. So this is going to be the height of the closed box or the rectangular box. Show that the volume of the box is given by this. Now we just write the formula for the volume. Therefore, let me just remove this line here. All right. So you'll just write the volume for the box. Then you substitute all the values. Remember, for the height, we are now going to be substituting with 20 over x minus 2 over 3x. From there, you simplify it. Then this is what we are having. Then we just proved that the volume is equals to 40x minus 4 over 3x cubed. The last question says what dimension will produce the maximum value, and then there we are going to be deriving with respect to x, and then you just write f v prime of x equals to, then this is going to give us 40 is true, and this one is going to be 4x squared. Then you equate it to 0 so that you can be able to solve for the value of x. Then you simplify, it's going to give us x squared equals to 10. Then just put square root both sides. Something is not right on this one. Let's see. The correct answer there is supposed to be square root of 10. That is the this is square root of 10. The square root of 10. Because if you say 40 divided by 4, it gives us 10. Therefore, this is going to be, it must be square root of 10, square root of 10, right? That is the answer. It's positive square root of 10. There, x is equals to what? Positive square root of 10. But because they are looking for the dimensions, you just have to do what? Oh, sorry, let me just remove that line. Let me remove this one and this one, and then this one. Let me just remove this one. All right, now because they are looking for the dimension, you just take this, the value of x, but because the breadth it was, or the width it was x, then we know this side is square root of 10. And then what about the length? They say the length is twice, so it's 2x. So where you see x, you just substitute with square root of 10, there's going to be 2 square root of 10. And the height, remember the height is this one, you just put square root of 10 there, square root of 10. You press your calculator, then you'll find the dimension of all these sides, or all the box. And then we still have another question. A farmer wants to make a rectangular chicken run using existing wall as one side. He has 16 meters of wire fencing. If the length of the chicken run is y meter, and then with the expression of the right expression for the area. What we have from the scenario, we can see we are having the perimeter, because perimeter is the distance from this point here up to this point, right? From this point up to this point, then we are having that 16 meter. Then when you start writing the perimeter first, and then we agree that the length, I mean the width will be x, as is shown on this picture. That is the width, and the length is y. The perimeter is now p equals to 2 it's no longer 2, but it's now length plus 2 with why do we exclude 2 is because for the length we have only this side, because this side, yeah, it's already existing, it's a wall there, so there was no need for us to include this side, because we cannot put a fence on that side because there is a wall there, existing wall. We're only focusing on this side, so for length we have only one side. We substitute, we make y the subject of the formula, so this is what we're having. Now we can start writing the area. You substitute, that is the area that we'll be having. We have answered the question. The second question, find the dimension of the chicken run. That will give the maximum area. Then you write the area that you got from question 1. With respect to x, we're going to derive that. Then after derivative, you're going to have 16 minus 4x. Then equate to 0 so that you can be able to solve the value of x. You transpose this one to this side. Then you're going to divide both sides with 4. Then x is going to be 4 meter. But because they are looking for dimensions, you can just take, you can see this side is 4 meter and this side is 4 meter. To get the length, you just take this 4, you substitute there, then it's going to give us what is the length. What is the length? Then it's going to give us all the dimension. Then the length is 8 and the width is 4. Rate of change. When you are dealing with the problem where the variable changes with respect to another, then you will always use differentiation all the time. Now let's see the example so that we can be able to understand that statement. During an experiment, a learner must record the velocity of an electronic toy car over a distance meter, and then t second that experiment has begun. The velocity of the electronic toy is given by this formula. The first question, determine the initial velocity of the toy car. Let's see on how do we calculate for that. You write the given equation, you substitute with 0, because when they talk about initial velocity, the car is not yet started, the time is 0 there. So that is the how you do, and then the answer is going to give us 8 meters. It's going to give us 8 meters. Number 2, the velocity of the toy car is equals to 0.2 seconds. That is the velocity of the car. Let's calculate for that. And then where you see t, you just substitute with 0.2 second. Then the answer is going to give 8.76 meters per second. All right. The third question says the rate at which the velocity changes. Remember, once it starts changing, we then have to do what? Derivative. We derive differentiation, where time is 1.2 seconds. And then you write the equation, then you derive it, then it's going to give us 4 minus 2t. Therefore, where you see t, then you're going to be substituting with 1.2, and then this is what we're getting. That is the answer, 1.6 meters per second. That is the answer for that. So that is the rate of change. Integration. After completing the integration, you must be able to apply the standard form of the integrals as a converse of differentiation. Apply the rules for the integration for the functions, and then apply the integration to determine the magnitude of an area, including by a curve and the x-axis, or a curve, the x-axis, and their ordinates where x equals to a and x equals to b, where a and b are element of integers. Let's see what we are having under integration. Determine the following integral. Integral of -6 over x dx. Let's see on how do we answer that question. Now, it's going to give us -6 ln x plus c. Don't forget to write this c all the time. When you're working with integration, we always include plus c, all right? So this rule, I believe we all understand on how do we go about it. When a denominator is x with the exponent 1 there, then it will always be a ln. It's going to give us ln. So it will depend on the number on top. There's a numerator. For instance, you can see this one is now -6 over x, then it's going to be -6 ln x. It's always the case. The second one is x minus 1 all squared. And then before we can start integrating, we have to open the bracket and multiply. Then it's going to give us x squared minus 2x plus 1. Then now we can start integrating. Then it's going to give us x cubed over 3 minus 2x squared over 2 plus x plus c. Don't forget to write c. So that is the answer for this question. Determine the following question, the integral. Let's see on how do we go about this one. First, we have to separate all. Then we're going to say 2x to power 8 over x cubed plus x to power 5 over x power 3, like we did here. And also this the same applies with this one, dx. Then we're going to simplify it, and you can see that I'm still continuing with the integral sign. Why? Because I haven't started integrating. I'm still fixing this. Then we can see now the final stage is this one. Everything is fine. I can now start integrating. Then I say equal sign. Then I do the integration rules. That is what I'm going to be having. All right. And then we have evaluate the following integral. And this one, we had a similar question on this one. Remember, it was -6. Then I don't think it's going to give us a problem. Let's see. The answer for this one is going to be +3 ln x plus c. That is the correct answer. The second one, remember here it said dx, so we are integrating with respect to x. And then this is what we're going to be having. Then it's going to give us x cubed over 3 plus pi x plus c. The last one is this one. We are now integrating with respect to t. Then it's going to give us this t cubed over 3 plus t squared over 2 plus xt plus c. So that is the answer for that. That is the answer for that. All right. All right. Thank you very much, my dear learners, for being with me on this interesting lesson. It was very interesting. And then before we can end this lesson, I just want to leave you with this note, which says, never give up. Today is hard. Tomorrow will be worse, but the day after tomorrow will be sunshine. So those are ways that I want to leave you with, grade 12s. I thank you. Have a nice evening. Bye.